Hi, I'm Chris Sikora, and I'm going to step you through Exercise 1, SolidWorks 2021. In this exercise, we're going to take a look at how to build that model that you see in front of you. Some of the features that we're going to look at, first of all, are just basic sketches, extrusions, fillets, that's the radius that you see here and here. Okay, and let me turn off the integrated preview there. And then chamfers, that's these angled edges. And then we're also going to learn how to put a hole in. And we will also learn how to shell it and make it a thin-walled plastic part. So let's begin. First of all, you'll find this information if you like a written document or some form. You could just go to vertanu1.com and get to the instructional manuals, go to SolidWorks Basics. And in there, it will actually bring up a document. I already have it up and loaded. And here you can see the SolidWorks Basics document here. And you will see it has a syllabus in it. This is a college course. So if you're wanting something that's 5 minutes, find a different video, because this is actually going to teach you how to do it. Just like you wouldn't want a brain surgeon working on you that only had 5-minute tutorials on YouTube. I wouldn't want to hire a person who learns SolidWorks using 5-minute videos. Anyhow, let's go ahead and get started. Okay, once you go into the training guide, you'll see that there's lots of different things you could look at in here. It goes through what I'm about to cover. And really the lesson, though, if you want to fast forward, you could fast forward a few minutes into the video if you just want to see how the part is modeled. But I'm going to go through some of the settings and things like that. So as you can see here, exercise 1 starts on page 19. We're going to go through how to build this. This gives you step by step. It's really just notes. It's not really a great training guide, beware. But we're looking over here. Once we finish that part, exercise 1, we go on to the labs. And the labs are saved as L1 and L1B and L2 and things like that. But you can see right here, there's 2 parts for you to build after you complete the model. And it uses the same tool. We basically use the same tools that you see in the exercise, of course. There are a few things I might show you, though, that are added value. Now, going back to SolidWorks. To get started, after you've installed it, go to New, and it will bring up this. You have parts, assemblies, and drawings. The first 4 weeks of this course are just part files. The 5th week, we look at assemblies, and then the 6th week, we get into drawings. 7th week is a review week for the midterm exam, and then the 8th week you actually take the midterm exam, turn it in. So, and all these videos are in sequence on YouTube under Vertanu1, or you could go to the web page that I just showed you. It has all the parts that you're going to need, everything that you would possibly need except the software. You have to get that on your own through SolidWorks or wherever. Okay, so I'm going to go select part. Now there is an advanced option here too, and you'll see part, assembly, and drawing. Now, I made a template, and I don't get into making templates until like exercise 6, or you could watch a different video if you like on that. But I already made an A and C inch. Now, when you go to part, it will give you options for those things. Not all the time, actually, if you're in the novice section. So it will just give it to you. And usually when you install it, it just defaults to the ISO standard, which international standard. Whereas I'm out of the United States here, so I'm using the American National Standard, or ANSI. Okay, now you'll see over on the left, let's go through the interface. This is the Feature Manager design tree. This is very interesting because this was, the first time I ever saw this was in the 90s with SolidWorks, and it's just really nice how it works. It basically is your roadmap of everything that you're going to do. It's going to contain all the features and things like that that you could edit from here. Or here's the view screen, or the viewport, you could edit it. There's a WCS just to let you know your X, Y, and Z. SolidWorks, you don't really need to use X, Y, and Z all that often. You'll see it's broken down into front, top, and right planes. Very simple, very easy to use, and pretty neat. Now you'll also see in the Feature Manager design tree, there's material not specified. If you right click on that, you'll see it gives you some basic materials, and it will actually input data on those specific materials, like the weight and characteristics of it, also the color. Now, you could go to Edit Material and you get a much larger library. And you can also procure additional libraries if you don't see them here, or you could customize this down at the bottom and create your own custom materials. But let's say we wanted this to be and aluminum. So if I go to aluminum alloys, and let's go with 1060 alloy. And here you could see I have mine set to megapascals or MPa. And we could see the yield strength, tensile strength, all that fun stuff. So go ahead and hit apply and close. You don't have to do that part unless you want to, but later on we could actually find out how much our part weighs. So if we're going to order material, you can find out how much you need, or how much it's going to weigh, I should say. All right, now let's go to the Sketch tab. These tabs, they call it the ribbon, and it's just like Windows Office. So you have the ribbons on almost all typical Windows software nowadays. And inside you have the icons. And I have some people say they don't like using this, and you can customize it. And you can just right click, and there's toolbars, and you could select from the toolbars and bring them up individually if that's your preference. And you want to right click over here. You can right click on the toolbar, but just be careful because you might undock it. You can actually unlock it, and actually you saw there, drag the command manager by the tabs to unlock. So you are able to move it, and then there's little docking stations you have to drag and drop it back into. Okay, let's go ahead and also let's go to the options menu. I just want to show this to you. So if you go to the little gear up here, we'll bring up the options, or what is referred to as the heart of SolidWorks. Here you have system options. These are global settings. Whatever you change there is going to be permanent inside SolidWorks. Of course, you can go back and change it. But document properties, which is the next tab, only affects the current document we have open. So if we say you're moving between metric and inches documents for different customers, this is how you could do it. You could adjust the properties just for the specific document that's open right now, or up and active. Here you could go to units, and here you could actually see all the basic units. You have imperial or IPS, inch pounds second, or millimeters grams second, things like that. Again, in the United States, I'm going to go ahead and use IPS today. So make sure that's selected. And then over here, you have the ability for decimal place precision. Let's set it to 3 decimal places, 0.123. You could go up to 8 decimal places. And for right now, that's about it. Oh, one last thing, drafting standard. If you're not in the ANSI, make sure you select ANSI. And it's not the end of the world if you don't. It's just the dimensions appear a little bit different than this. All right, let's now select the front plane. And right here, you'll see a quick launch that appears. If you don't move your mouse too fast, it's there, and that's great. I love the quick launch. However, if you move away from it, it disappears. Now, you're probably wondering, what are these planes? Those planes are your paper that you sketch on. And we're going to sketch on the front plane for the next 4 weeks. I will show you a couple instances where you could click on the top plane. A lot of people ask, like, what's the point? Like, how should we design? And I always tell them, like, if you're going to design something, like let's say here's a mouse, and you're thinking, okay, well, what's the front, top, right? Or better yet, actually, it's here's like a lip balm. And essentially, you have to figure out what's front, top, and right, and you could sketch that. So this is a cylinder, very easy to model pretty much. So you might want to sketch it from the top where you just draw a circle, and you could extrude it later. So you could sketch it on the top plane and then extrude it up, and it will be sitting vertical in the interface. But to be truthful, it doesn't matter all that much, all that often. Once you understand your spatial recognition inside the software, you can do pretty much anything you want. All right, but we're going to sketch on the front plane. So select the front plane, go to the Sketch tab, and start a sketch, because, of course, I blew through the quick launch, which would have given me the same exact option. All right, it oriented me normal to the plane, or so you can see here, we're parallel to it. And you have an origin. That's your origin is not movable inside SolidWorks. You can add additional WCSs for output to other CAD systems. That's not, or CAM systems. It's not as critical as it used to be, but you don't move this origin ever. That's your anchor point, and you'll see it's awesome the way it works. Okay, now find the tools up here on the Sketch tab. You'll see there's a variety of different tools. Typically, anything you see here, you're going to see in a different CAD system too. But hit the little arrow to the right of corner rectangle. You'll see that there's center rectangle. We're going to use that. I'm going to show that one to you for Lab 1B today. So if you continue and watch that, I'll show you a cool trick with that. But we want corner rectangle. Now move your pointer to the origin. You'll see the origin turns. First of all, your pointer is no longer a pointer. It's actually a pencil. And it turns, whenever you hover over something, you get that little orange dot. You want to make sure you get that orange dot. And to the right of the pointer, there's a little symbol, and that's what they call a constraint that's automatically being added, and we'll talk about that in a second. But once you have that, click one time. And when I referred to the mouse buttons, this is in the training guide. When I say click, I'm referring to the the left mouse button. And that's when we use 90% of the time. The right mouse button, we only use maybe 10% at most, okay? And that's for bringing up context-sensitive menus. And I'll make sure I tell you right-click, and I'll say it slowly, and perhaps I might even say it twice, just so you know. Then there's the wheel. The wheel, many people don't realize it's actually a push-button mouse, too. It's actually a third button if you hold it down instead of scroll. But we're going to talk about that in a little bit, too. That's for zooming in and out and things like that, and rotating. But let's go ahead and move our pointer to the upper right. Now you'll notice on the left-hand side, there's some parameters. Now, I've been using SolidWorks since 1997, and I was an applications engineer. And I've seen places where I've had people use that in the left, and then they fail to use the Smart Dimensions tool. And what happened is that actually a company I worked at, someone accidentally moved a line because it doesn't really constrain it, threw the whole model off. It ended up getting molded, and we're talking $30,000 of a mold that was no good, basically. And so I don't recommend using that. In that case, the owner of that company said it was a fireable offense to use that from then on. So not saying that that's every company, but I would not recommend that. It is nice for plugging in numbers quickly, but don't use it. Now look to the upper right of your pointer. You get X and Y information, and this is just to get you close to the marker. So let's just get it up here to where you can't go any further, or you don't want to go past. Go ahead and click, and you'll see little green squares. Now those green squares are indicating vertical and horizontal constraints. It's locked in, so it's not going to tilt at an angle because it automatically put those in for us. Now we could click on it, hit escape, click on them, and hit delete if we didn't want them, but then we could get a parallelogram where basically or not even parallelogram, where they basically just drag them at an angle, which that might be what you want, but not in this case. All right, now this little constraint here indicates that it's locked in at the lower left. So it's on our anchor. Let's go to Smart Dimension. Now Smart Dimension, if you hit the little arrow underneath it, there's baseline dimension, horizontal ordinance, vertical ordinance, things like that. We're not going to go through all those right now. We will take a look closer at them maybe in 6 weeks in exercise 6 for detailing. But for right now, just use Smart Dimension. It's actually pretty smart. Go ahead and click on this line. Now, I see a lot of people who migrate from like AutoCAD and some other CAD systems. They end up clicking on the points because that's what they're used to in those systems. That's an extra point every time. You don't have to do that. Just click right on the line. When the line turns orange, click, move your pointer to the right, and you'll get the dimension. Now, if your dimension is horizontal or vertical, that means that you're probably in the ISO standard. So go back. You could go to that little gear up here and change that. You could also go down here, and there's an option to change it there. But it doesn't matter to me. Whatever, if you want to use the ISO standard, that's fine. ANSI standard is fine too. Just center the dimension like so. Click, and make that, type in. Now notice this. You can see the 8 decimal places. I've had students, and I've been training. I also used to be, I used to hire people as well. And when I would give them a test to see their skill level, I would generally, this is what I would look at. If they went ahead and they did this, this is what not to do. Like they click in here and they backspace. I've seen this multiple times, and I was guilty of it when I was a new user. So don't feel bad if you do that. And then they type in 5.000. They're like, oh, because yeah, we have 3 decimal places, and they hit enter. It's going to work. But as a manager, I'm going to look at like, oh, this is a novice user. This is a beginner. So let me show you a trick on how to look professional, like you really know this software well. Do this instead. Like now, go ahead and click on this line here. Drag the dimension down, center it, click. Instead of typing over that, notice it's highlighted in blue. Just hit, oh, and also make sure on your keyboard, make sure the number lock is on. And now just hit the number, like 3, and hit enter. Look at that, 3.000. It filled in the decimal place and the zeros. So that makes a person look much more skilled with this software. So if you're looking for a job for this and the manager sits you down and says, let's see what you can do, and they give you a drawing, make this, try and do that. You're going to look very impressive and hopefully get the job. All right, let's go to features and go to Extrude Boss Base. All right, go ahead and type in 0.5. Now, features is the 3D area of SolidWorks. Sketch is the 2D area. Now, there is a 3D sketch, but 3D sketch is really reserved more for piping, tubing, things like that. It is pretty nice, very nifty the way it works, but we'll look at that in exercise 7, so stay tuned. All right, so we typed in 5 here. Notice we have from a sketch plane. We're not going to get into that right now. It's a little bit more on the advanced side, but it's a very nice tool. Blind, if you hit the little arrow to the right of blind, you'll see there's up to vertex, surface, body, midplane, things like that. We just want blind. Blind is a given depth, and we can type that in at 0.5, as you see right here. And if you know what the equivalent is in metric, just so you know, you can always type it in, and like you'd be able to type in 0.5 with the little quotes or IN, lowercase IN, and hit enter. If you're metric, it will actually convert it for you, which is really pretty cool, and vice versa. Type in mm for millimeters, but leave it at 0.5. Hit the green check. Now you have your first solid, perhaps, maybe. Okay, now hit escape. See the blue edges? That's just highlighted because that was the last thing we did. If you hit escape on your keyboard, that disappears and refreshes. Now some of the settings in here, like I have shadows and all this fun stuff, where you'll find that at, I have real view graphics. Some of you may not have this or the ability to select real view. Real view gives it just that, but it says real view graphics. Like NVIDIA with their Quadro series of cards does it automatically, as well as the Radeon Pro or Fire Pro series from AMD. Typical CAD gaming cards don't have it built in. There is a cheat under not configurations, but regedit, and you can look that up on YouTube. I don't recommend it. I've tinkered with those, and I've had them screw up my system more often than not. I mean, I got them to work, but Quadro graphics are just nicer, the professional graphics. Otherwise, it looks like this. So yours might look like that. That's fine. It's still perfectly usable, but I'm going to go ahead and turn on the real view. You can see the shadows. Maybe I don't want to see the shadows. I'm going to turn that off. There's also ambient occlusion. It gives it a little darker. We don't have anything really to reflect too much off of, so I'm going to turn that off too. All right, now we're going to go ahead and continue on with this. We're going to build a block at the bottom. So select this face, and we'll use the quick launch. Notice the quick launch toolbar just appeared. Otherwise, you could go up to the sketch and the little sketch button there. You could do that too. But right here, click on this icon. All right, now I want to show you how to rotate a little bit. First, using the keyboard. Hit your space bar. The space bar may or may not bring this up, depending upon the computer you're using. You have this little vector, a view selector, and I really like this. I call it the ice cube because it brings up this little ice cube. If you turn it off, it disappears. But you turn it on, you have this, and you can click on any of these polygons, and it will bring you to that view orientation. Space bar. Click on that polygon, brings you to isometric, spacebar. And also it gives you a list here too. You can also break this up into 4 views, those of you who like that, which is really nice for other CAD systems. I've never found it really all that useful for SolidWorks, but I've seen people use it, and it's okay. All right, but let's go hit the spacebar, click on front. You also, if you hold the right mouse button down, hold the right mouse button down, move left or right. Look at this. You have some quick launch tools there too. I'm not going to select any of those. We were in the sketch tool, so it was going to let me do that from there, but I wanted to go ahead and click on here. Now, mine is really, I'm getting this terrible shadow effect. Now, click over here on this little beach ball, and I'm going to go to plain white, and that helps lighten it up a little bit, but there's other ones in there too. Feel free to tinker with them. They're really neat. Okay, let's go back to corner rectangle. Go to the lower left corner, click, and drag this to the right. Now, as you glide along this right edge, you'll see it will highlight in orange. Now, if you move close to the midpoint, guess what? You get a midpoint. We don't want that. That would be an automatic relation we're not interested in. So drag this down a little bit. Like we want y to be around 1.5 inches, around there. So click. Now go to Smart Dimension, click on that vertical line on the right, drag it to the right, and click. Now, you might have missed it because I didn't call it out. I'm going to cancel for a second. I'm going to hit that red X. And Control and Z one time will undo. Okay. Oh, I'm sorry, I had to hit it a second. I'm not sure why I had it the first time. But anyhow, I hit Control Z. That's undo. Now, there is the undo button up here, and there's redo too. Look at it tells you Control Y is redo, Control Z is undo. Now, notice this line here is like a lighter blue, and this is black, and then it's shaded inside. What do those things mean? That blue indicates that of that line that's underdefined. There's no constraint telling it where to be exactly. So this is where it could be dangerous if you don't dimension things, because look at that, you can just move it by clicking and dragging with the mouse button depressed. So we want to eliminate that with the Smart Dimension. Click on this line here, click over here to the right, type in 1.5 and hit enter. And now it's turned black. Black is an indicator that it's fully defined, and that's what you want before you go into production with anything. Anything that's underdefined, SolidWorks will let you go into production or send it to the 3D printer or whatever you like to do, but be aware that you might not have measured that. And this is a good way to checks and balances for yourself. So you'll also see down here, it will tell you when you're fully defined as well. It says fully defined right there. The other term would be underdefined, meaning you're missing either one of the two types of constraints. Let's look at that right now. The two types of constraints, you have dimensions, and that's using the dimension tool. And then you have these little green blocks, which have all been automatic thus far. We're going to see how to manually put one in a little bit. But those are also constraints, telling it to be vertical, horizontal, perpendicular, tangent, all those fun geometric type constraints. Okay, let's now go to Features, go to Extrude Boss Base. Now, if you want to see this extruding, like right now it's extruding out at us, so we can't really tell, but watch this, I'm going to show you a little trick. The mouse wheel, if you have a mouse wheel, hold it down like it's a button, don't scroll. Now scrolling will zoom in and out, but now move your mouse on the table left, right, up, and down. That's dynamic rotation, so that's how SolidWorks does it. All right, now you could also zoom in and out with your wheel. Like move your pointer where you want to, like this upper right corner. Let's say you want to move up or zoom up to that area. Hover over it and start scrolling towards it. And that's how you could get a focal point, just by hovering your pointer over where you want to focus on and rotate. Okay, you could go ahead and hit enter or the green check mark, and we now have our next block. Again, you could hit escape to refresh the screen. Let's put a hole in it now. Go ahead and select this face and go to the sketch, or I'll go up here to the long way. Just go to sketch. Now just to show you, if you hit the little arrow under sketch, you'll see sketch, 3D sketch, 3D sketch on plane. Remember, 3D sketches are great for tubing, wiring, pipes. Not so great for what we're doing now, so don't bother with the 3D sketch, just the regular sketch. All right, hit the space bar. You could actually, we'll use this button right here, front, or Control 1 is the fast key. Well, there is a hole tool, but we won't explore the hole tool until exercise 4. Okay, and the hole tool itself is for counterbores, countersinks, national pipe threads, things like that. It actually has a nice, robust library to choose from. This is just showing you how to draw one manually, and then we're going to go ahead and cut it. So hover over this upper left quadrant, click, drag out, or just move your pointer out to create a circle. Now sometimes you'll hear me say drag out, and I had someone comment like, oh, that was confusing, and I apologize. SolidWorks does let you drag lines, like just like if you were to hold a pencil down and drag it across, holding the mouse button down, and when you release it, it automatically releases you from line chain. So there is that option, and I apologize because that's how SolidWorks used to function on a regular basis. And so if I say drag, I just mean click and click. I don't usually use that old tool, which I don't really find it all that valuable these days. Okay, go to Smart Dimension, click on this circle, drag this up here, click, and 0.75 for the diameter. Now we're going to locate that. So select the center point of that circle, click on this edge here, and I'm going to use my wheel to zoom out a little bit and click up here, make that 1, because it's 1 inch offset from the left edge. Now you can actually click on the actual circle and then the top edge, and it gives you the same option. It automatically goes to center. It does give you some additional options sometimes for going to quadrants, which we'll look at that maybe around exercise 4. Some built-in functionality. There's a tremendous amount of built-in functionality that I'm not showing you, because it would just overwhelm a new student. So we're just looking at the very basics. And this is how SolidWorks, I've been teaching it since 1997. I add some of the enhancements that have come over the years, but essentially you could almost go back to an older version, probably up to 2001, and use these same functions. So they've been in there for a long time. All right, let's go to, let's rotate first of all. So middle wheel, hold it down, rotate it a little bit. Now, we're going to see how to cut material. This is where SolidWorks is very unique. Like FreeCAD does this. There's some others that do it, but not all of them. A lot of them have it integrated into the Extrude button, but this has actually a separate button for removing materials, which is called Extrude Cut. Click on Extrude Cut. Now, one thing about this, SolidWorks is a parametric modeler, meaning those dimensions, we could later on go back into them, double click, and have it change and update. And that's one of the beautiful things about parametric modeling. However, there is something called design intent, and that's how your plan, how you want it to react when changes come down the line. Someone tries to change it, so it doesn't error out or do some strange things. And no matter what, it's going to happen. But it is a skill over time that you'll develop. I don't suggest thinking about too deeply right now, but let's see an example of design intent. Right now we have this going, it's a 1/2 inch. It remembered the dimension from the wall thicknesses that we created. Now a 1/2 inch on that single plate would go through right now, but changes come down. What if that plate changes, someone says, you know, the plate's not thick enough, let's make it 3/4 of an inch, so 0.75 instead of 0.5. This hole will have to be changed too. So you'll have to go in later on and change that. That's extra step for you. Or someone might not even realize it, and the part goes out to be manufactured, and it's wrong, because the hole is no longer a through hole. Here's the fix for that. Instead of blind, use through all. Now there's a through all both, but that would be if there was something in front of the model that you want to cut as well. So you don't need that here. You just need through all. It's going backwards. SolidWorks has a little bit of an AI built that basically is built in that knew that there was volume behind it, so it automatically picked extrude that direction when we select the extrude cut. If we were actually adding material, it would flip-flop it the other way. It's not always so smart. Sometimes you have to help it along, depending upon the complexity of the model, so just note that. All right, hit the green check. Now, let's take a look at that. Double-click on this side face here, and you'll see the dimensions appear. One of them up here is the thickness. Double-click on that 0.5, and you could use this as a wheel. And you'll see it update. See how it's making it thicker? Let's say we made that thicker. And then you could, this is a preview regenerate. See that little traffic signal, that red light, green light? Click on that. It commits partially. You could actually see the preview. And however, though, it essentially, yeah, you can see the preview. And then you just hit the green check mark to apply it. If you don't like it, you could hit the red X. But notice it goes through because we select through all. Okay. Go ahead and just hit the red X to cancel that operation. Now, it's still in a thickened state, so hit this rebuild or this regenerate up here, or Control B, and it'll go back to its original state. But if we wanted to keep that, we would have hit the green check mark instead of the red X. So there you go. There's some information for you. Now, let's take a look at Fillet. Technically, we're done. In my training guide, this is all I expect my students to do. This next area is an enhancement that's going to make you a better modeler. If you want to do this for the rest of your life, watch the next few minutes. If you don't want this as a career, you're just taking this because you have to, you're done. You don't have to go any further. Turn this in, do a file, and do a, let's see, a save as, and you can save it as a PDF. First, you probably want to save it for yourself, but there is a, let's see here. Okay, there it is, PDF. Adobe Portable Document Format. Click on that, hit save. Save it as E1. Well, I'll actually make one right now. So click here and capital E1 for exercise 1. All of your exercises should be turned in that way. Exercise 2 will be E2, exercise 3, E3. Your labs will be L for lab 1, lab 2, lab 3. And those numbers go by the exercise. The exercises are typically the opener to the chapter. That's your chapter, basically. And so it would be E1, E2, E3. Those we do together. The labs, I recommend you do those on your own. Okay, I will give you videos for most of them. So, because I don't want to see anyone get stuck. I used to have students call me and say, hey, how do I can't figure out how to get this to work. Now I put the video in there, but I still recommend you do them on your own. You'll be a much better modeler. Go back and take a look if you get stuck. All right, so capital E1, hit save, and you just save the PDF. Send me the PDF, those of you in my class. Or later on, you could save these and make a portfolio. Okay, I'm going to save actually the part now. I'm going to go to Save As instead of there. It's going to say SolidWorks Part. And I'm going to save this. I made actually my Documents folder a SolidWorks 2021 Parts. And I'm going to name that E1. And that's how I'd want you to save it. Now we're going to go to the Fillet tool. Find Fillet up here. Now the Fillet tool enables us to put a radius on. And we're just going to look at the basics here. Set the radius to 1 for 1 inch. And select the edge. Like I'm going to rotate this. See this edge right here? Click on that. Now to get it to this isometric view, if you can't figure out how to use the mouse wheel, remember the space bar. Now you'll have to close the Fillet tool, I think, before you hit the space bar. I don't think it likes it when you do that. Let's try it. Yeah, see, it just alters this, so we don't want that. But you could cancel, hit the red X if you need to. Now, if you can see these, though, click on this edge. SolidWorks does do something rather unique. I've only seen it in 2 other CAD systems where it allows you to select faces. Now, we don't want any faces here. Now, this would be a face. See this whole face right here? And you get a little symbol to the right of your pointer. It's a blue square. I don't want you to select the face. If you do select the face, all the topology of that face gets filleted. And sometimes it can't handle that, especially with this large of a radius. So there's not enough room there to put that in, so it's going to error out. So be careful not to do that. If you do, like here, I clicked on it, notice the preview disappeared. Make sure you turn on full preview, by the way. I don't know if it's always on. It used to not be on by default, so full preview in order to see that. But look at that. See, I just clicked on that. They disappeared. That's an indicator that it's not going to work, because this is only 1/2 inch thick. It can't fit a 1 inch radius on that. So click on it again to deselect it. And there you go. So just these 2 edges that I selected, hit the green check. Now let's try a chamfer. Hit the little arrow underneath Fillet and you'll find it hiding in there. It's chamfer. Chamfer is an angle versus a radius. Make sure over here you type in 0.125. Make sure full preview is turned on. Select this edge right here and this edge here. If you wanted to, you're welcome to try it right now. You could click on this edge. I encourage you to have fun with this at this point. Remember, I only require the basic model. If you want to make it look really impressive and tinker with it, and you're going to learn a lot, put more stuff on it. Put more fillets, put more chamfers, learn how to sculpt. Like I could put in a chamfer like this. At that point, though, what you're looking at is it's a countersink. All right, and here notice that we have 0.125 at 45 degrees. You could do a variety of things, distance to distance, angle to distance, so on and so forth. Hit the green check. All right, we're almost done. Rotate this. Now practice rotating till you get this view. Remember, middle wheel. Hold it down. Move your mouse left, right, up, and down. And take a break. Learn how to, right now, pause it if you like. Try rotating around. Rotating is a very important skill. I know some think like, well, we're talking really basic. What is he talking about? But no, new users who've never used a 3D CAD system, this is time for you. Take a minute or two, learn how to rotate. It's going to make your life a lot easier. Okay, welcome back. So let's go to the shell command. Now with the shell command, we'll make the wall thickness 0.1, which is the default. Now what you do, you just select what you want open. So click on this back face. There is a show preview. I'm not a huge fan of the preview in this one, but that's okay. Click on this face here and click on that face. Now those are the faces it's going to remove. Everything else is going to have this thin wall, and you can kind of see it in that preview. You can also shell it outward. I don't want you to do that. That would thicken it on the outside. We don't need it here. Hit the green check. And now look at that. Look at this beautiful part that we've modeled. Very simple, but yet it has some nice elegance to it with the fillets and the chamfers. Now let's look at some of these keys. Your arrow keys on your keyboard. Hit them. It rotates in 15-degree increments. Try up, down, left, right. Now, if you hold the Alt key and the left and right arrow keys, it rotates clockwise and counterclockwise. If you hold Control and the arrow keys, it pans. If you hold Shift and the arrow keys, it rotates at 90-degree increments. If you hold Shift in the middle wheel, it's zooming in and out, and that's just like scroll too. If you hold Control in the middle wheel, it pans left, right, up, and down. If you hold the right mouse button, now you get these options, like you could go to top, bottom, left, right, and that's with the right mouse button. And up here, you have zoom to fit. The F key on your keyboard does this. Okay. There's also zoom to area, so let's say you want to zoom up on that hole, you just click. You can hit zoom to fit again. There is previous view, so it takes you back to the last view. We have section view, click on that. Now the section view, grab the arrows, drag it through, grab these rings and rotate it, and you can drag through it at any angle, seeing it. Now if you hit the green check mark, you'll see it leaves you with this, which might not be desirable. So turn off section view to stop that. You can actually partially work in that mode, which is pretty cool. There are some limitations to it though. All right, there's dynamic, we're not going to go into that. View orientation, that's what we've been hitting with the space bar. And then finally over here we have the shade with edges, shade without edges. We can go over to wireframe, hidden lines, and this one, integrated preview. That's if you have Photoview 360, it gives you a nice shaded, professional looking image. All right, now at this point, let's go ahead and take a look at why did we select that alloy first of all. Take a look here, click off of it, hit escape. You could go to the evaluate tools. Now evaluate, you could go to measure. Now the measure tool is really neat. You could say, oh, like, what is that? Click on that line. That's 2 inches. Now if you hit this little arrow, you could clear that out. Now, like, let's say we want to see what this radius is. Click on that. And there it gives you the information. Okay, so you could measure things really easily with that little tape measure. Now here, mass properties. And what we could see is that with this specific 1060 aluminum, the weight of this part would be 0.1 pounds, so a tenth of a pound. And you could change that. You could go over here to options and use scientific notation, use custom units, all that fun stuff. All right, we could close that. Now let's take a look at changing colors. We're going to go ahead, we already looked, see it has an aluminum facade. That was because we selected the 1060 alloy. But you could override that. Let's say we want this hole to be a different color. Click on that, and then right here is a beach ball. Hit the little arrow underneath it. You could say the face, the cut extrude, the whole body, or the entire model. You could adjust. But let's go to the cut extrude, which is just the hole. And now over to the right or the left, you have different colors you can make. That, see how as I click on the color rainbow here, you can change the colors. Or you could go over here to plastics, find like high gloss, and there's a whole variety of plastics to select. You could select high gloss blue. There's also car spray painted, and like there's gloss blue. Okay, and it looks a little bit different. Now, we could also select from here, the chamfer. We could right click, Or we could do this. Actually, let's say we wanted to steal that color. We could right click on that cut extrude, and right here is copy appearance. Click on the chamfer, and there's paste appearance. So you're able to put it back in. There's several different ways and tricks for that. At this point, let's set this up for rendering. So go to perspective. Perspective gives it a vanishing point. And now if you go to, not every system has this, or every license. So if you go to SolidWorks add-ins, see if you have Photoview 360. If it's grayed out or if it's not there, that's an indicator you just have the core modeler. Photoview 360 comes in the professional version, which some schools will procure, some don't. We have it at the college that I teach at, so you do have this technically. If you depending upon what class you're in, you get different licenses. All right, so at that point, we could go Photoview 360, go to Render Tools, and go to Integrated Preview. Now, if you hold on, I have a bit of an older computer here. I'm going to do Control-Alt-Delete and hit Task Manager here and go to my performance. And you can see it's rendering it, and you can see that it's utilizing all 16 threads on my Xeon processor. And the speed of my Xeon is 3.6 gigahertz. And I have my GPU. It's not using much. It actually looks like it is using some GPU performance there. A very minuscule amount, but this is the Quadro K5200, which is actually a rather old, from 2014, I believe, card. 8 gigabytes of RAM, but this is a professional card, and I got this for, believe it or not, $100. Normally they're like $300 on eBay or higher. It depends. You really have to shop, and I got this because they had an issue with one of the ports, I think, is out on it. But it has 4 ports, so it wasn't a big deal. Okay, so there you could see it's finished with the threads, but it is a multi-threaded process, this rendering. So the more cores you have, the better. Let's take a look now in the training guide. Now that we've finished this, let's go to L1. Now you could save your part, just hit File, Save. It should save over the last one, or save as if you want to rename it or something. But L1, we see a 2 by 3.5 inch, looks like an F, right? We're going to go ahead and model this, a 2 by 3.5. So go turn off Integrated Preview because it does suck up system resources if you leave it on. Now we go to File, New, and ANSI inch, just part is fine for you if you want. Again, if you need the units changed, down here is a quick way to change them to IPS for inch pound second. Go to the front plane, start a sketch. We're not going to change the material type here. Draw out the line. Now, we didn't learn the line tool. It's kind of an assumption drawing the rectangle that works the same way. So click on that origin, drag this up. Now notice when you do an individual line, though, it doesn't constrain you to vertical. So you have to kind of move your pointer to make sure it looks vertical. And you see the little symbol to the right of your pointer? That's vertical, that little yellow vertical line. Years ago, it used to have a V for vertical and H for, I thought I'd like that, but of course, it's an international product, so it doesn't have that these days. So 2 inches approximately, click. Drag this across here about 1.5, and then drag this about halfway down, about 1 inch. Drag this over about 1 inch, drag it up, across, down a little bit, and just have a little fun with it. This goes a little lower, click. Now, if you can get the inference line, look at that, I'm inferring to the origin, click, and now connect that. All right, hit escape. Now let's go to Smart Dimension tool. Click on this bottom line, that's going to be 3.75. Now it's going to do some scaling. Click on this line here, that's going to be 2. And then click on this line here, and let's see what that is supposed to be. That's supposed to be 1 inch, and the next one is 1.75. So this will be 1. Now to get that baseline dimension, we're just going to do it manually. There is an automatic tool for it. I'm not going to show that to you right now. Click on this line to this line, 1.75. Now they do have tools later on. I always suggest that it's good to lay these dimensions out, how you would like to see them on your drawing, because you can retrieve them in the drawing when you make it, and it shows up just like that for the most part. But there are tools that allow you to automatically do it too. All right, click on this line here, click on this over here, and maybe zoom out a little bit, get that dimension over there, and we're looking at that's going to be 2.5. Okay, those are all constrained. Now notice this one is not, and that's fine. Let's take a look. We want this one right here to be 0.85. Oops. And from here to here, this will be 1. Now this one we could add a dimension, but you notice my print doesn't have it in there. So what you need to do, hit escape on your keyboard. I'm going to show you a little trick how to manually add a relationship. We want it to be aligned, or what they call collinear, to this line here. So click on that line one time. Hold Control then for the second entity. You always have to hold Control. That's typical Windows functionality. If you're selecting multiple files, you hold Control. So click on this line here. Release. And now you get this quick launch. And look at this. You could go through here, and there's collinear. Now you could go over here too, and it has them spelled out for you, collinear. And now you'll see that little dashed line. It ignores that for the extrude, but it notes that it's aligned now, and we're fully defined. So I'm going to go to Features, Extrude Boss Base, and select 0.5. Type in 0.5, hit Enter, and hit the green check. Click anywhere on the screen, and basically you're done at this point. Again, feel free to enhance it. Use the fillets. Go to the Fillet tool. Feel free to put some fillets in on some of these edges. Enhance it, because later on, the purpose of this class is for you to learn it, as well as make a portfolio that you can show off to potential employers. And when I used to hire people to do this, that's one thing I would do, is I would actually look at their portfolio if they had one. Believe it or not a lot do. But if they had it, they would automatically go to the top of my list, because I could see exactly what they were capable of. Go ahead and put a few more in, and just have fun with it. All right, let's move on to the next one. For this one, we have a 3x5 block, and it's 1.5 inches thick with a cutout that goes 1 inch deep. And then we have some holes in it, offset 3/4 of an inch from the edges, and they're 1/2 inch holes. So let's begin. For this one, actually let's save this first though. I'm going to go save, and this one is capital L1. Oops, capital L1. Let's see. All right, now we could go to File, New, Part, hit OK. Again, if you need to change this, I'm not going to show you today how to do a template, but you can select the IPS right down there, or you could go to this again. All right, I'm going to do this on the top plane. Let's just see what happens if we do it on the top plane. Select the top plane, start a sketch. This time, let's show you a different tool. How about the center rectangle? When something is symmetric, like this block, automatically try center rectangle. Click on this center here, drag this out, click. Let's go to Smart Dimension, 5 by 3. Now let's put the holes in. Select one of the circle tools, and stay away from the geometry here. Click and drag out a small hole. Don't touch the edges. Stay away from the edges. Now go to Smart Dimension. Dimension the diameter of the hole at 0.5. Oops. And now select the center of the hole to the left edge, 0.75. Center of the hole to the top edge, 0.75. Wow, it's really close there. All right, now what we can do is we could do that each time, and that's good practice. But how about I show you a new tool? This tool doesn't really, we don't go until next week usually, but let's go ahead and try it out. Let's try the mirror tool. The mirror tool requires something, the center line. So click on this little arrow to the right of line, find center line, and hover up here till you get the inference to the origin. Click to connect to the origin, and then click to the left. Hit escape. Just as long as it's centered, that's all I care about. I don't care what order you draw it. Now, This is how you, if you hit escape, select the circle, hold control and select the vertical center line. You can only do it across one center line at a time. Now, at least last I checked. Now go to mirror entities. Mirror it over. Let's try that again. Select the hole here. Now hold control and select this. Now you could do this too. Watch this. What if you didn't want to do that? You could like move your pointer over here, surgically go in and just encompass or in an envelope those two holes without anything else completely encompassed. Now hold control and select this line. So you could use that too. Always go from left to right if you're trying to surgically get in there. Otherwise, if you go from right to left, it selects everything that it touches. So that's typical of other CAD systems too. All right, let's go to mirror entities. There we have it. We saved a lot of time. See all those additional constraints that are there? Now we could go to features, extrude boss base. Let's make it 1.5, which is the overall thickness. Hit the green check. Click somewhere. Now select this face, start a sketch, space bar, go to top, go to center rectangle again, and right at that origin, click, connect to this upper edge right about there. We're just eyeballing it right now. Go to smart dimension. It is supposed to be 1.5 wide. Go to features, extrude cut. You may want to rotate this to see there. See, it's going through right now, so we just want it to go 1 inch. Just 1 inch. Oops, I hit the wrong button. There, 1 inch. Hit the green check. Done. Now, if you hit the space bar and go to isometric right here, or Control 7, there we have it. Let's add some fillets. Go to the fillet tool, and again, just for fun. You don't have to do this. Just enjoy yourself. This is really, you could be as creative as you like with these. Go ahead and type in 0.5 for the radius. Select this edge here. And some ask, like, could we have added this in the sketch? Absolutely. We'll learn that next week or the week after next. All right, now to get this one behind here, you could rotate, but SolidWorks employs kind of like a Superman X-ray vision. You can just hover over where you think the line is, and it will highlight. Click. Hit the green check. Let's put some chamfers on there. Go to underneath fillet, go to chamfer. We'll stick with our 0.125. I like that size. Click on this edge here. Click on that edge there. You could even click on this entire face and look at that. All right. And let's say we want to add that and that too. Hit the green check. Now you have a very interesting looking model. All right. Now let's enhance it with some colors. Select these 4 faces for the holes. Now go to the appearance, the beach ball. Hit the little arrow to the right of the big beach ball. Go to face. And let's go to plastic. Actually, let's have them illuminated. Go to lights. Go to, I actually like the neon tube. It's actually pretty neat. And let's go to blue neon. Or actually, let's go with green just for fun. Hit the green check. And if you want, you could also go here. If you want the whole body, you could just go ahead and click on the part at the top. Here, right click, go to the beach ball. And right here, this is for the entire part. So anything you change is going to change, except when we select those faces, that trumps the overall part. So here we can go to the part, and let's go to plastics, high gloss, white high gloss. Green check. And hit your space bar, go for isometric, and let's turn on perspective. And you could also try ambient occlusion. See how it darkens it there? That's not realistic. These are supposed to be glowing, so let's see what it does when we render it. Go to the render tools. And remember, you may not have the render tools. If you don't worry about it. It is what it is. It is an extra module. So click on integrated preview. And again, I have a slower computer. It's a bit dated. Dates back to several years ago. And you can see those holes are kind of glowing. It's not the best rendering right there. But you could have a little fun with it. I wouldn't recommend the lights for the inside there. I don't like how that looks. It's kind of blah. All right. And that concludes. Oh, before I do that, if you want to make a portfolio, those of you in my class, here's how. There is actually, if you type in E0 SolidWorks, you'll see a whole video on how to make portfolios with more rendering and things like this. If you have, there's a product called LibreOffice, L-I-B-R-E, Office. Just type it and Google it. It's free. You could use that. I'm going to click on it. And there's also Microsoft Word. I have an old version of Word 2010. And let's see the differences here. All right, here's LibreOffice, and it looks similar to Word. Here's Word. Now, let's say we want, I'm not happy with that rendering, but we'll use it. What the heck? While it's rendered, hold Alt and hit Print Screen, especially if you have multiple screens. It will only pick up what's selected. Now, here's Microsoft Office. I could type in E1, hold Control, and hit V as in Victor. And it should drop in a printed screen. Some of you might want to leave this here to prove that you modeled in SolidWorks. Others, feel free. In here, there is actually a crop. Let me, if you go to View, actually click on this first. Go to Format, and there's Crop. And then you can just grab these corners and crop out what you don't want to see. Click off of it. And then you have the ability in Word to enhance it. Like there's corrections, so you could lighten it so it blends in more with your sheet of paper. You have a little fun with it. There's a bunch of different things in there. Now, if you don't have Word, here is LibreOffice, which is free. E1, Control V, same thing almost. Click on here. If you right click, crop appears on the drop down, and really it works pretty much the same way. Now, one nice thing about LibreOffice is it doesn't anchor it to the left every time. So you can move this anywhere you like. You could drag this out. Just don't grab the middle. Then it stretches it. And when I'd see portfolios like that, I'd cringe. Because it's like, oh, it's not how it's supposed to look. You want it to look proportional. Okay, now here, notice this one can't really be moved. So to move it, you right click and you go to Wrap Text and go to either behind or in front of text. And then you're able to move it wherever you want. And then you just move on down to the next one. You could go to Insert, Page Break, and now you could start an E2 or Lab to whatever. Okay, and just copy and paste those in. So there's some tips and tricks for making a portfolio. My students, you have the option. You could either turn them in, the exercises in the labs, at the end of the semester with a portfolio like this, or save them as PDF and send them to me as you go. However you work best. A portfolio in the end is not required. I just need to see the actual PDF part files or a Word document. Don't send me the part files. You'll clog up my email system in no time. All right, so please just do it this way, and that's it. Thank you very much for watching. I hope you enjoyed this. Have a good day.